Alright, so we'll be doing number 7, or no, number 11. Wait a minute, what question number is this? Wait, it's 7. Okay, we'll do number 7. So this, we have to find dy over dx, which is y prime, and we always have to write this down. Okay, so y prime of t over x prime of t. Y prime of t is derivative of y in respect to t, so this will become 25, derivative of 25 is 0. Derivative of negative 6 cosine squared is negative 12 cosine of t sine of t because of chain rule. And then if you take the derivative of cosine, we'll get negative sign. So all the negative sign will go away here. And then derivative of negative 12 sine of t, which is just negative 12 cosine of t. And then this is all over the derivative of 2 sine of t. So we'll just get 2 cosine of t. Cancel out the cosines here. And then we can simplify this. We would get 12 sine t minus 12 over 2. And then we would factor this out here. Sine of t minus, uh, yeah, minus 1 over 2. And then this would cancel out. We would get 6 sine of t minus 1 is equal to, and then 0, because, hold on a minute. Yeah, so, but actually, we don't have to, this actually makes it hard. We can just leave the answer so that it's just 6 sine of t minus 1. And then we don't have to really distribute it. Actually, it doesn't even matter. So 6 sine of t minus 1 is equal to 0. We have to set the this expression here equal to 0 because horizontal tangent line is when the numerator is equal to 0. So this has to equal 0. Divide 6 by both sides, we'll get sine of t, and then we move over the 1, and sine of t is equal to 1. So at what point at t is sine equal to 1? That would be pi over 2. So this is t when the the derivative has a tangent line. Now we have to solve for what point x and y is. So we can do this by um, plugging into the original equation. So we would just do x pi over 2 and then y pi over 2. Um, we plug pi over 2 in here, sine, you'd get sine of pi over 2. Oh, I did something. Sine pi over 2, which would just be 1, so x is equal to 2. And for y, we plug in pi. 25 minus 6 cosine squared pi over 2, that just becomes 0. So 25 minus 12 sine pi over 2, 12 sine pi over 2 just becomes 12. So it's 24 minus 12, which is 13. So it's 2 and 13. We would just basically plug in pi over 2 into the original equation. All right, next question. Um, let's see. Oh, I forgot. Actually, never mind. We can do the parametric equation involving with thetas. So this will be the last one. Okay, this one, it would just do we would try to isolate the trig functions for these one to write it in Cartesian form. So x over 5 is equal to sine of theta. I just divided 5 by both sides. For y, we would just do y over 2 is equal to cosine theta. Now we have to do sine squared theta plus cosine squared theta is equal to 1. This is the Pythagorean theorem. And then we know that since sine of theta is equal to x over 5, we know that x squared over 25 is equal to sine squared plus y squared over 4 is equal to cosine theta. And then this would just all equal 1. So we want to write it into this Cartesian form, y squared over 4. So all we need to do is just subtract x squared over 25 to here, both sides. So we would just get negative x squared over 25 plus 1. And that would be your answer. This is y squared over 4, like that. Pretty simple. Um, let's see. Oh yeah, let's do the last problem. The last problem without a calculator is pretty brutal, so I'm going to use a calculator. Very time consuming because you have to evaluate a definite integral with a lot of like variables in it. So here it is. Okay, we have to find the how many units of distance are covered. So this the unit of distance, we have to use the arc length formula for this parametric functions. So arc length of a parametric function, we could do your a to b square root of dx over dt squared plus dy over dt squared dt. And then this formula would get us the arc length. So following this formula, we have to find the derivative of x of t, square that, find the derivative of yt, and then we would get, and then we square that, and then put all of this over a square root, and then the interval they give you is 0 to 4. So let's write all of that down. 0 to 4 square root. So we know that dx over dt is equal to 2t plus 25. If we square this, so we would pretty much get 2t plus 25 squared plus dy over dt, we would get 2t plus 25. Wait, no, I made a mistake, guys. This is supposed to be 32. dx over dt is, wait, actually no, it doesn't even, oh wait, no, I was right, never mind. Alright, continuing on. This will just become that. 2t plus 25 squared. And then you evaluate this integral. Um, and if you do evaluate it, use a calculator. I think you're supposed to use it. Honestly, I don't think you can get this without a calculator. You would get 164. For this equation, you'll get 164.048.